Hello and welcome back to Dr. Logic awkwardly does logic in her office. Let's talk about proof rules. In my previous video, I defined a notion of proof being this finite list of propositions where each proposition has an annotation indicating either it's an axiom or it's the result of applying one of our rules. In order to actually do a proof, you need to know what the rules are. There are 4 types of rules that I'm going to introduce you to. Don't worry, not all of them in this video. I will do one video for each of the types. But we have bookkeeping rules, which are basically rules about how to get started and how to kind of make sure that our propositions are where they need to be when we want to use them. Transformation rules, which take individual propositions and change them into other propositions. Rules for applying axioms, so that will tell you when are you in a position to actually use one of these foundational items that we identified a couple videos ago. And then we will have a hypothetical rule or a hypothetical method for proving some of the tricky syllogisms. So in this video, I'm just going to talk about the bookkeeping rules. We have 2 of them. Now they are best defined if I can draw them on the board. So here we go. We've got our whiteboard. The first bookkeeping rule that we have, so bookkeeping rules. The first one is the premise rule. This rule says that if psi1 is the major premise of a syllogism and psi2 is the minor premise, then you can start off a proof by writing psi1 on line 1 and psi2 on line 2, and both of these will get annotated with premise. Now I'm going to draw a little line here just to show that we are separating the premises off from the rest of the proof. Now, we will always have 2 premises to start with because this is what the syllogisms look like. You have a pair of premises and you're trying to derive a conclusion from them. So every proof that we start will start off by writing down 2 categorical propositions, labeling them 1 and 2, and annotating them with premise. That is the premise rule. Now, let me talk to you a little bit more about the way that we've set this up. So these here are the annotations. These here are the categorical propositions. These are the line numbers. This line, this blue vertical line, is the scope line, and then this just, in a sense, sets off the premises from the rest of the proof. Now, the purpose of the scope line and of the little bar that sets the premises off from the rest of the proof, that will come out when we're using the hypothetical method. So don't worry too much about this kind of structural notation on the side until we get to the rule where the video where we talk about the hypothetical rule. But every single proof that we write is going to be starting off in exactly this fashion. Now, because I've put these annotations onto my annotations, I now don't have enough room. This is something that always happens when you're doing logic. Your whiteboard is just never big enough. Anyway, I'm gonna have to clear the whole thing, clear all drawings. And I will just reiterate so that we remember what it is that we're doing. We are talking about the bookkeeping rules, of which the first one is the premise rule. The second bookkeeping rule that we have is called reiteration. And basically what reiteration says is if you have a proposition already in your proof at a particular line, you can write it down again at another line. That's all reiteration says. If it's already in your proof, you can write it down again Now, you might think, why would I ever want to do that? I've already got the formula. Why do I need to write it down again? This has to do with some of the other rules that we will introduce. The rules are very sensitive to the particular structure of a proposition or of a pair of propositions. So sometimes we need to be able to put the formulas in the right order in order to be able to apply a rule. That's why this is one of the bookkeeping rules. It doesn't really say anything substantive. It just makes sure that everything is set up right so that we can actually apply the more substantive rules. Anyway, the rule of reiteration says that for any lines in your proof labeled I and N. So I and N are just any number that is one of the numbered lines in your proof. So for any number, any lines I and N, if phi occurs on line I and I occurs earlier in the proof than N, so I is smaller than N, and N is within the scope of I will say what that means in just a moment. If those things hold, then phi can be written on line N. And the annotation is reiteration line I. So let me draw this out so that you can see what it would look like. So say we've got some proof. So, it's got line 1, got line 2. Who knows what formulas have been written here? However, we do know that they're going to be annotated with the premise rule because, as I said, every single proof starts off with putting down your two premises in lines 1 and 2, annotated with the premise rule. But then, who knows how many other lines that we have? Say that we now have line I with some formula phi on it. Again, we don't necessarily know what annotation it has. It's probably going to be one of our substantive rules that I'll teach you in later videos, but it has to be annotated with something, otherwise this isn't a proof. Then again, don't know how many other lines might be in here, but eventually we reach line N. We are able to write categorical proposition phi on that line again with the annotation, reiteration, line I. Now, let me go back to what I said about, so if phi occurs on line I, that's what we have right here. If I occurs in the proof before N does, that's what we have here. And then we need to have this idea of N being within the scope of line I. And here's where the scope lines play a role. You look at, well, what is the scope line that N is on? Follow it up. Does I occur on that same scope line? In this case, the answer is yes. So these are the three things that we need to check in order to determine, is it legit for me to put line formula phi on line N and justify it with the reiteration rule on line I. Now, at this point, it may not be intuitive when you would ever want to use reiteration, even though I've already said that we'll need to do it in order to make sure that we have kind of the right structured proof in order to be able to apply some of the other rules. It's hard to see what can be meant by that until we get some actual examples. For now, think in terms of shape and structure. That is what you are interested in when it comes to proof. We are not dealing anything with what the sentences mean or whether they are true or false. We are just interested in how can we make this list of formulas in such a way that it meets the definitions of being a proof. So finite, everything is a categorical proposition. They're numbered, and every line is annotated with one of our rules. So now you've got two rules. I can give you a sample proof. So we know that our first line is always going to be some categorical proposition. Let's say PEM, and annotation premise, and then a second categorical proposition, which can serve as a minor premise to the first proposition's major premise. So let's say SIM. There we have another premise. We've got our scope line already. We draw the little line underneath in order to set our premises off. And now reiteration says, if I have a formula on a line and it's on the same scope as a later line in the proof, then I can write that down again. So this would be reiteration of line 1. Now, if I wanted to, I could extend my proof by reiterating line 2. This is getting to be a very boring sort of proof, but it is a legitimate proof. Now, suppose that I write down PEM again on line 5. Well, this is a reiteration, but is it a reiteration of line 1 or is it a reiteration of line 3? Trick question. It doesn't actually matter whether I'm repeating this particular formula or this particular formula because they are the same. It is exactly the same categorical proposition. So whether I want to say that on line 5, I'm reiterating number 1 or number 3, it doesn't make a difference. Anyway, here's a proof. Look at that. You're already at a point where you can start doing syllogistic proofs. It's not an interesting proof. It's not a very useful proof, but it is a proof. Now, join me next time, and I will give you some actually interesting proofs because we will get the transformation rules that we need to actually change up the actual propositions that we are writing down. So that's when the fun begins. Join me next time. Cheers.